Okay, so the recording has started, so let's start as well. So we are going to talk about solving systems of equations by graphing. And first of all, let's discuss what it means to be a system of equations. So um, whenever we have to, let's say we want to find two integers and find their sum and difference. So any two integers, an integer means a whole number. It could be positive or negative. So for example, let's say we're going to use 5 and 6. Then 5 plus 6 is, of course, 11. And then we're going to find the difference of these two integers. For example, 5 minus 6, which is, of course, negative 1. So here we know what the numbers are, but let's say we didn't know what they were. So then we would have had an equation where we want to find these two numbers. We want to find this 5 and 6. So, but we do know that their sum is 11 and their difference is negative 1. Now keep in mind, sorry about this weird. So keep in mind that this result of adding and subtracting these two numbers will happen only with the two numbers. So there are many different ways to find the sum of two numbers equal to 11. But if you subtract them, that the difference will not necessarily be equal to negative 1. So the only time when that happens, that both the sum and the difference of these numbers is only with the numbers 5 and 6. Okay, so therefore, only if x is equal to 5 and only if y is equal to 6. These are the only options for these two results to be true. So therefore, a system of equations is when we have two or more equations that have to be solved together. So we have to find such answers that both equations are satisfied, that both of them work. So that's what we call a system of equations. It's when we have two or more equations and we need to find solutions that will work for both of these equations. And here we're going to start straight away with an application question with a word problem. So let's say you have $20 in your bank account and you start saving $5 each week. And then you also have a friend who has $5, only $5 in their bank account, but then they're saving $10 each week. Okay, so you have $20 and you save $5 each week, and your friend has only $5, but then your friend saves much more money. Your friend saves $10 each week. So let's first of all, we want to write out the equations for the situations. First of all, we want to write down what our variables represent. So our independent variable, which is x. Well, independent means it doesn't really depend on anything. It will happen no matter what. And one of the things that will happen no matter what is the time will go on, and our time is measured in weeks, since we're saying it's $5 each week. So x will represent the number of weeks. Then y is a dependent variable, and that y will depend on x. Well, in our case, what depends on the number of weeks that you're saving money? Well, how much money you have in the bank account. So this is going to be total money in the bank. So then we can set up these equations. So we're going to set up the equation for you and then your friend. So the equation for you, we want to, so we have the money in the bank, so that would be a dependent variable. So y depends on x. And then we know that we're starting with $20. So you have $20 no matter what, even before you started saving. So that's your constant. But then you save $5 every week. So you take $5 and you multiply it by how many weeks you have. So you have the equation y equals 5x plus 20. Then for your friend, we will have a similar equation. So y is the total money in the bank. Now your friend only has $5 to start out with, but then your friend saves $10 each week. So you take $10 and multiply by the number of weeks, which changes. So these are the two equations. These equations will represent how much money both you and your friend will have in your respective bank accounts. Now, the second question is, well, when will you and your friend have the same amount of money in your accounts? Well, that means that we need to find when both y's will have the same value. Well, to do that, we can graph the equations. So notice that both equations are already in a y equals mx plus b form. So we can find our slope and y-intercept for both of these equations, like we've done many times before. So the equation for u, the slope is going to be equal to 5, or we can write it as 5 over 1. And the y-intercept will equal to 20. Then the equation for your friend, the slope is going to be 10, or 10 over 1, and the y-intercept is 5. So let's graph these equations. We have the graph on the right side. Be careful, notice that on the y-axis, we go by 5. And on the x-axis, we really go by 1. So we have 0, then 1, 2, then 3, 4, 5, 6, 7, and so on. Okay, so for the first equation, for the equation that represents your amount of money, we're starting at 20. And then we're going up 5, 1 to the right. And once again, notice that our distances are by 5 already. So go up 5 to 25, and then 1 to the right. Up 5, 1 to the right, and we continue doing this as long as we can. And please notice that I write all of those points down. The more points you have, the better, the more accurate your line will be. And then we draw this line, and that's the line that represents you. Notice I did not draw my line to the left. The reason why I didn't do that is because on the left we have negative values. But remember, our x represents the number of weeks. We cannot have negative number of weeks, so we don't actually draw the line on the left side. If it was just a regular equation, we would have, but since this is a practical application, we have to also remember of the context in which we're working. Then for your friend, we're starting at 5, and then we go up 10. So please remember, each square is each space is 5, so this is 5 and then 10, so we're going to 15 and over 1. Then we're going once again 5, 10 over 1, and then we continue 5, 10 over 1, 5, 10 over 1. So oops, sorry about this. So we have all of these points, and we're drawing the line through these points. So now the question is, well, where and when will you have the same amount of money, and what is that same amount of money? Well, remember that y represents the money and our x represents weeks. So both lines that represent you and your friend, so this is the pink one is for your friend, they both intersect right here. This is where both accounts will have this amount of money, $35, and it will happen after this many weeks, which is 3. So we have the point of intersection, this point right here, that has coordinates 3, 35, which is your x and y coordinates. So that means, since that's where the lines intersect, that's when the amount of money that both of you and your friend will be the same. Therefore, you and your friend will have the same amount of money. And in the parentheses, we can say that it's going to be $35 after not even after, but let's say at 3 weeks. And the reason why I'm saying it's at 3 weeks and not after 3 weeks, because after your lines intersect, notice that they go opposite directions. So once 3 weeks have passed, you at the 4th week now you have different amounts of money again, and you can think about which one of you will start having more money after those 3 weeks. But when you've been saving for 3 weeks exactly, at that moment both of you will have the same amount of money. So this is a situation where we had to use a system of equations, because we had to create two equations with two variables, x and y, and we had to find solutions that will work for both of these equations. So notice that if I substitute my values 3 and 35 into x and y, my equation will be true in both cases. So let's actually do this. So if I substitute 35 for the y coordinate into the first equation, we'll have 35 equals 5 times, and now we're substituting 3 for x. And then we'll have 35 equals 15 plus 20, and therefore we have the left side equals to the right. So this equation is true. And the same thing will happen also for the other equation. So if I substitute now 35 for y and 3 for x, it will also produce the true equation. So let me show that really quick. So we'll have 35 equals 10 times 3, but then plus 5. So then we'll have 35 equals 30 plus 5, and then 35 equals 35. And we see that both equations are true. So this point right here, this 3 and 35, produces the answer that works for both equations. Okay, before I continue, are there any questions? And if you have questions, please just unmute yourself, or you can write in the chat. Okay, then let's summarize what we've just learned from this practical application. So what is a solution to the system of equations? Well, a solution, notice, is an ordered pair. One second. So it's an ordered pair, x and y, that makes both equations true. And in other words, when we're looking at the graph, a solution on the graph is where the lines intersect. Yeah, right, that's a little nicer. So that's where the lines intersect. So here we have just some examples of the lines that are already graphed for us, so we don't need to graph anything. And here we can see that the point of intersection is our solution. So we need to know the x and y coordinate. So if we look at the x-axis, we get the value of 3. And if we look at the y values, we see that it's at -2. On the second example, this is the point of intersection. So our x-coordinate of this point is 2, and the y-coordinate is -1. Now, for the next example, we have two lines that are parallel. Therefore, they never intersect. Well, if the point of intersection is a solution and these lines never intersect, well, then there are no solutions. No solution. And then for the last example, we can see that the point of intersection, we have the x-coordinate, which is 3, and the y-coordinate, which is 4. Okay, so that's if your graph's already done for you. And here we have the summary of it all. So if we have two lines that are intersecting, then you have only one solution. That's where the lines cross. This is one point. And that happens if two lines have different slopes. Then, if we have no solutions, we call it sometimes NS, no solution, if the lines don't intersect, if they're parallel lines. And the parallel lines have, that happens when their slopes are the same. Remember, we talked about parallel lines in the past, and we talked about that parallel lines have the same slope. But also they have different intercepts, because otherwise it would have been the same line. So same slope, different intercepts. Finally, we have infinitely many solutions. We are also abbreviated as IMS. And that happens when we have identical lines. So this is really hard to see in this picture because it looks like you have only one line, but that's because you basically have a line, put in different colors. So we have, let's say, this red line, but then the second line is identical to this one. Therefore, it will lie exactly on top of it. So in other words, they intersect infinitely many times. That's why we say that we have infinitely many solutions. And that happens when then you have both the same slope and same intercepts. Have the same slope and the same intercepts, or in other words, the lines are identical. Now, could a system of equations have more than one solution? The answer is no. At least not if it's a linear system. So in our class, we're going to talk about only linear systems of equations. So those have only one, they can have only one solution at most. Actually, no, this is incorrect. I just contradicted myself because we can have infinitely many solutions. So sorry, this would be yes. You can have one solution or you can have infinitely many solutions. So the answer is yes. However, can you have exactly two solutions? And now here, the answer is no. The only options that we have are, you have either one solution, you can have no solutions, or you can have infinitely many solutions. There are no other options. Okay, so now let's look at some examples. And here it's all about the graphing. That's why we had to review graphing in the beginning of the year, of the semester. So first we're going to graph both equations, and then we're going to find a solution from the graph. So the first equation, as we can see, is already in a y equals mx plus b form. And we, of course, can imagine 1 to be out in front of x. So for the first equation, we already know that the slope is 1 and the y-intercept is -8. Therefore, we can graph this line. So we're going to graph this in red. So we're starting at -8. And then our slope of 1, we can, of course, write it as 1 over 1. So we're going to go up 1, 1 to the right, up 1, 1 to the right, and so on. Now, please notice that I'm putting all of these points on the graph. We want to put all of the points possible because we want the line to be as accurate as possible. If you have a ruler, you don't need to do it necessarily, though it still would be helpful. But especially if you don't have a ruler, please put as many points as possible because you want your line to be as accurate as possible to see where the lines intersect. Now, for the second equation, we notice that it is not in a y equals mx plus b form. So we have to rewrite this equation in y equals mx plus b. Well, to do that, first of all, we have to move 4x over. And to do that, we have to subtract it. Now, remember that when we're moving the 4x over, or when we move the x term over, we want it to be in the front. So we're going to put negative 4x in the front, and then positive 2 we're going to put at the end. Then we, of course, have to divide both sides by 2. And therefore, we'll have y equals negative 4 divided by 2 is negative 2x, and then 2 divided by 2 is 1. So now from here, now this is a y equals mx plus b form, so we can figure out the slope and the y-intercept. And the slope is, of course, negative 2, or we can write it as negative 2 over 1, and the y-intercept is just 1. And we're going to draw this line in purple. So starting at 1, and then we're going down to 1 to the right, down to 1 to the right, and so on. And once again, notice that if we put all the points down, we can draw a very accurate line, and we can very accurately see where the lines intersect. On the other side, we can also do the same thing to make it more accurate, like this. So these are two of our lines, and our answer, don't forget to actually figure out the solution, is the point of intersection. So it's this point right here, and we can see that it has these coordinates, as coordinates 3, negative 5. And therefore, that is our solution. Coordinates 3, negative 5. Okay, let's do another example. So here we have something a little tricky. We have x equals negative 6. So we need to remember what kind of a line that is. And we need to remember that when you have x equals to just a number, then we have a vertical line. So this red line is our x equals negative 6, is just a vertical line up and down. Now, our second line is 2/3 x plus 1. Well, this one is already in the y equals mx plus b form, so we know the slope is 2/3. We know the y-intercept is 1, so we can graph this line. So we're starting at 1, and then go up to 3 to the right, up to 3 to the right, and so on. But then we also can go down to, and then 3 to the left. And once again, we want to write down show all of the possible points, so we have a very accurate, we know accurately where the lines intersect. So that's our second line, and this line is y equals 2/3 x plus 1. And we can clearly see the point of intersection. The point of intersection is right here. So we have the x coordinate, and then we have the y coordinate. So the coordinates are negative 6, negative 3. Okay, before I continue, any questions at this point? Once again, you can either write in the chat or unmute yourself and ask me a question. Okay, then let's continue and see some other examples. And it looks like we're doing the same thing over and over, but there are actually some special cases that we also need to see when they happen. Okay, so we have the next equation, a system of equations. So we have x plus 2y equals 4, and y equals negative 1/2 x plus 5. So for the first equation, notice that it's not in the y equals mx plus b form, so we need to put it into the y equals mx plus b form. So I will copy down this equation over here, and now let's write it in the y equals mx plus b form. So to do that, we're of course going to move x to the right, and we'll do that by subtracting it. Then we end up with 2y equals, remember we always want x to be first, so it's going to be negative x and then plus 4. It will also help us to put 1 in front of x as a coefficient. Then we are going to divide everything by 2. And therefore we get the slope-intercept form y equals negative 1 over 2, or we can write it as just negative 1/2 x plus 2. So please notice that this is our equation. And now from here, we can easily see that the slope is going to be negative 1/2 and the y-intercept is 2. So we can graph this line. So we're starting with 2, and then we go down 1, 2 to the right, down 1, 2 to the right, down 1, 2 to the right, and so on. And we also can go the other direction. And we can draw our line. Now, for our second line, the one that we're going to graph in purple, this one is a little bit easier because it's already in the y equals mx plus b form. So we already notice, we know the slope and the y-intercept. And some of you might have noticed something. Notice that the slopes of these two lines are the same, which means that they will be parallel. So at this point, you already should know what the answer is. But we can also see it visually. So we're starting at 5, we go down 1, 2 to the right, using the slope. And after we graph the lines, we can see that these lines are parallel. And we already knew that they were parallel because they have the same slope. And if the lines are parallel, they never intersect, which means there is no solution. Okay. Let's look at another example. So on question 9, once again, our second equation is already in a y equals mx plus b form, but we still need to graph the first one. And to do that, we have to rewrite it in a y equals mx plus b form. Okay, so as always, we have to solve this equation for y. So we're, of course, moving 4x to the right, and we do so by subtracting 4x. Don't forget about this negative in front of the 2. Keep in mind it's still there. So we have negative 2y equals negative 4x plus 8. Remember, we always put the x term first. Then we're dividing both sides by negative 2. So we divide everything by negative 2. And therefore, we end up with y equals negative divided by negative makes it positive. So it becomes positive 2x. And then 8 divided by negative 2 is negative 4. Oops, I'm sorry. I just realized that the 8 was negative. So that actually will change some things here. Sorry about that. Okay, so yeah, then 8 is negative. So here we actually have negative 8. Therefore, it's negative 4x minus 8. And when we divide it by negative 2, it becomes positive. And that actually shows something. Notice that our equation that we just got is y equals 4x plus 4. And the equation that we already had in the slope-intercept form is also y equals 2x plus 4. They are identical equations. That means the lines will lie on top of each other. So our red line starts at 4. And then we're going up 2 over 1 using our slope. So here, let me write this out. The slope is 2 over 1, and the y-intercept is 4. So we have our red line. But then the purple line is exactly the same. It also starts at 4. And we use the slope 2 over 1. So it lies exactly on top of the red one. So they intersect constantly. They intersect infinitely many times. Therefore, the answer is infinitely many solutions. And once again, we do have some abbreviations. You are welcome to use them. So no solutions, you can write no solution and S, and infinitely many solutions, you can write IMS for infinitely many solutions. Okay, so notice that's the example when we have infinitely many solutions. Okay, last two examples. So for question 10, both equations are already in a slope-intercept form. So for the first equation, the one that we're going to graph in red, we know the slope is equal to -3 and the y-intercept is equal to 4. And of course, the slope should be a fraction, so we're going to write it as -3/1. So we're starting at 4, and then we go down 3, 1 to the right. Down 3, 1, 2, 3, 1 to the right. And remember, we want to draw all of the points. We want to plot as many points as we can to make our intersection accurate. So that's our red line. Then the purple one is y equals 3x minus 2. So the slope is 3/1, and the y-intercept is -2. So we're starting at -2, but now we're going up 3, 1, 2, 3/1, 1, 2, 3/1, and so on. Now here we already see where they intersect. We already see that they intersect right there, so we don't need to draw all of the other points because we already know the main part that we need to find out. So we have this point of intersection, this big orange point, which has coordinates 1, 1. So in this case, we have only one solution. It's not any kind of a special case. It's just one solution with the answers 1, 1. Finally, the last example, we have both equations that are not in a slope-intercept form, so we have to rewrite both of them. So we start with the x minus y equals 3. It is helpful for us to put the coefficients in front of our variables. So you can put 1 in front of x and 1 in front of y. And now when we're solving this for y, we're moving x over, and since it's positive x, we're subtracting 1x. Now don't lose your negative, so have -1y equals -1x plus 3. And then we divide both sides by -1. So we have y equals negative divided by negative is positive, so we have +1/1x. 3 divided by -1 is -3. So this is going to be our red line, and we already can see the slope is 1/1, and the y-intercept is -3. So we can graph this line. Start at -3, go up 1, and so on. Now for our purple line, we have to rewrite the equation as well. So we have 7x minus y equals -3. And once again, we want to put 1 in front of y. So we're taking this 7x and moving it over. Therefore, we have -1y equals -7x minus 3, and then dividing everything by -1. Therefore, we get y equals +7/1x and then plus 3. So that would be our purple line. And here we know the slope is 7/1 and the y-intercept is 3. So we're starting at the y-intercept of 3, but then we're going up 7, 1, 2, 3, 4, 5, 6, 7/1, or down 7, 1, 2, 3, 4, 5, 6, 7/1. And then we can, if we try again, we're going to be gonna get outside of our grid, but that's okay because we have these 3 points and we already see where the lines intersect. We can see that they intersect right here. And therefore we have the coordinates of the points of intersection, -1, -4. So that's our solution, -1, -4. Okay, so we've done a lot of examples like this. So the main part here right now is for us to know how to graph lines. And as long as you know how to graph lines, this should be a pretty straightforward lesson. So please tell me if, first of all, let me stop the recording, and then please tell me if you have any questions.